Hello, my name is Mohit Deshpande, and in this course we'll be talking about the geolocation aspect of our social notes application. So, first off, we need an API key from Google Maps so that we can use Google Maps. In order to do this, we have to go to this website here, developers.google.com/maps/documentation /Android/maps-API-signup. Now, what you're going to need to do here is agree to these conditions, and you need a MD5 fingerprint from your data store, and we're gonna have to change this when we publish because the data store is going to be different. The data store that we use for debug is not going to be the data store we use for publish. So let's grab the MD5 fingerprint from our debug key store. Now, in order to do that, depending on which operating system you're running on, you're going to have to open up a terminal or a command prompt and make sure you have a key tool. I'm going to show that how to get it real quick here. You can see I've already gotten it, but once you're in the directory, you're going to run key tool -list -key store, and the key store should be the debug key store. Now it'll ask you for a password. The password for the debug key store is Android. And then this, what we have here, it says certificate fingerprint MD5. That is what you're going to copy and paste into here. And then click generate API key, and then your API key should be generated. Now, in the course on publishing this application to the Google Play Store, we're going to have to get a new MD5 fingerprint key for the release certificate. Alright. So in order to use the Google Map View, we have to declare a uses library, and the name of that being com.google.android.maps, indicating that we're using the map library. And we're going to take that API key we generated and put it right in here in our activity notes map file. Alright, let's go here to our notes map activity, and what this does is it creates a list of points on the map, and those points are the nodes. Alright, so you see it sends map activity. We have a tag, we have the projection, we have the map view object. You can see we grab a cursor from all of the nodes and we move it to the first one. You can see we grab the map view, and then we allow the map view to use the own built-in set of zoom controls, which you'll see. Now the map overlays. What map overlays is I'll get to that a little later on, and you'll see how it works. We have a marker, which is what the image is, where the points are. We have this is a custom class we created called Note Itemized Overlay, and that's a class, and I'll get to that. Now what this construct does is, this is a more complex sort of for statement, but essentially what it does is it goes through each item in the cursor, and then it executes all of this code that's in the block. So you can see, let's dissect this here. See, Boolean has item, cursor dot, we're moving the cursor to the first row, and this returns a Boolean to saying that is it the first row. And then if that is true, then we proceed. And then every time we're going to tell the cursor to move to the next one. And then if it has that item, then we're going to execute the code. If we get to a point where the cursor doesn't have any more items, then the for loop doesn't execute. And then you can see here we just grab all the columns from that certain row. I log it. Now, we stored them as pure latitude and longitude coordinates, where being like 32.36852 simple it would have to be within 2-digit numbers, of course. But now how Google's map view lays it out is they don't use floating point values at all. They just use really big integers. So in order to do that, we have to multiply our latitude and longitudes by this construct, and 1e6, and if you know anything about mathematics, that means 1 times 10 to the 6th power. And then we have this capital F here to indicate that we're multiplying by a float and not an integer, so it doesn't do any kind of rounding. Let's see, we create an overlay item at that point, the title of the note, and then the content of the note. And then we add that to the itemized overlay that we created, and then we add that to the overall map overlay. In this case, we only need to have, in this case, we only need to add in one kind of overlay. We don't have to have, like, multiple overlays. This is a mandatory function, is route displayed. We return false, there's no route. Now, what this extends is this extends balloon itemized overlay. Now, that's what creates these nice balloons. Now, you can go into here and clone this, or you can download it as a zip file. And we're going to be using this library, this free, like you can see the license on it. We're free to use this. So you would import it the same way. Go to File, Import, and then browse existing Android source code, and then you'll import it into your project. And what this balloon itemized overlay is, if I can show you on the map here, it's this. When I tap on this, you get a nice little balloon. That's really nice. So we're just going to use that. Alright, you see we have the overlays. We have an array list, a private array list of overlays, and we have a context. Now what this does is we have to call the super constructor, and then we're calling this bound center bottom. That's mandatory. See, we get the context from the map view, and then we call this method populate. I'll get to that in a minute. You can see populate is from itemized overlay. When we're adding an overlay item, we simply add it to the list. When we're creating an item, what we do is we return that from the index, and then the size being the size of the list. Now, on balloon tap, that is what happens when you tap on a balloon. So what we're going to do is we're going to get that overlay item, and then we're going to query for if that title equals the title of what's ever stored in the database. Now, this is only a little bit insecure in the sense that if you have a ton of notes with the same title, we're only going to choose one of them. So instead, what we can do to better improve this a little bit is, why not use the content? Now we'll see if we can get the content. Seems we can only get the title, so we'll have to use the title and move to the first one. And then what we do here is we grab the ID of that, and then we create an edit. We open the edit activity with that, with an action edit, of course, and then we use in that context we start the activity. All right, moving on. Going to the select location activity. Now, what's select location? I can't. I'm afraid I can't really simulate it on. I can't do this on the emulator because it requires multi-touch, and the emulator isn't meant to withstand multi-touch, I should say. All right. Well, we'll see what we can do here. Let me open a sample note. You want to change the location? Yeah, you can see it's Can't exactly simulate, but we'll try our best here. What this does is you select a location, you hit the back button, and that location is safe. And there's my computer fans running. Alright, see we have the obvious projection, and we have a geopoint, and that's the point on the map. Alright, we have the map view object, and you can see that most of the stuff is exactly the same as the nose map activity, except we really only need one. Alright, see how we're querying for that intent, and then the intent that we're receiving from here when we call in our add activity, that URI has the ID in it, so we don't have to worry about we really don't have to worry about is there multiple. No, because one node is unique to one ID. And you can see we grab the latitude and longitude here and convert to the appropriate map viewpoints. And then we set the new point being the point that we originally started with, and we add a marker overlay. I'll get to that in a minute. Is route displayed false. Now, dispatch touch event. This is interesting in the sense that we've customized our own map view. Map view really wasn't intended for us to like select points. It was intended to view points. But we have, because we're extending the map activity class, we have complete control of this, and this is a great demonstration of how if something doesn't suit your needs, change it so that it does suit your needs. That's what we're doing right here. MapView does not respond to any on-clicks because that's already managed by MapView, and so we have to override dispatch touch event. That happens when the map is touched. What we do is we clear all the previous overlays, and there's only one overlay. We invalidate the map, meaning it refreshes. Now, if this action is an action up, then what it does is it grabs the X and Y coordinates where it's been, and then it divides by 1 times 10 to the 6th, and then it adds a new marker overlay at that exact point, and then it refreshes the map. And then we have to call super.dispatch touch event. We have to pass that on to the super class, because if we don't, then we can't like move the map at all. Like we can't pan the map, we can't zoom in or out. Because if we return this to be true or false, then it'll only register touch events. It won't register like zooming, the pinch to zoom in or anything. Alright, now you can see in on destroy what we do right when you hit the back button is on destroy is called. Again, you can look at the official Android documents to see how that works. What we do is we grab content values and then update the note that we were given. Alright, marker overlay. This drops a marker whenever your finger is lifted. You can see we have a new marker overlay. It has to be at a certain geopoint right here. Now this onDraw method, you can see we have a canvas, a map view, a shadow, and then integer when. So we might as well call the superclass method first. Now point is what this get projection to pixels is we grab the point from the map view right here. This doesn't have any Java doc to it, but essentially what it does is whenever you touch it, that's passed on to geopoint, and then we can convert that geopoint into just points. It'll convert those geopoints into pixels on the screen. What we do here is what this marker is we're grabbing a resource. I just found like a little. I took the marker from the Google Maps application. I'm sure you can find them. You can use a different marker. You can use a little Android icon marker. You can use a globe marker. It doesn't matter what marker as long as it's in the drawer folder. Now, here's the interesting part. Then we tell the canvas to draw the bitmap at those X and Y coordinates. And you see we've kind of finagled it a bit by subtracting some points so that it fits evenly. Here, let me show you what happens when we just set it right there. Alright, let me just run the application. Oh, not registering our emulator. I see. That's okay, we're gonna have to start a new one. So we'll close out of this. Give a minute for the simulator. I'll just give a minute for the simulator to boot up here. Alright, you can see the emulator is finally booted up. Alright, sample note. Change the location. Now taking note that this will take the exact XY coordinates of the pixel. You can see that is... See, that's not at all where I'm clicking here. So what you're going to have to do is kind of fine-tune it so that it falls in the exact point. This is just relative accuracy. It's not really accurate. So what you can do here is what I have done is you just kind of add values that it can do that. Like, say if it's too much below, then you need to subtract from the y. If it's a little too to the left or the right, you can kind of choose what that is and then finagle it a bit. And make sure to always test this on a real phone. And you can see when I hit back on destroy, it should save that point. So that when I open the map, hey, look, that point's right there. Alright, one last thing I'm going to talk about here is how to grab current location using GPS Wi-Fi network providers. See, I've created a class here called My Location. I have a timer, a location manager, a custom class I called location result, GPS enabled, and network enabled. Those are all booleans. See, we create a location listener to listen for GPS. And when it changes, we cancel the timer. And what the timer does is every whatever I have set here, it'll refresh and try to get new coordinates. What I do is from the location result, I call this got location, and it kind of follows like an observer pattern, where when the user creates a new location result class, they would have to override the got location, and then it would give them a location object, so that allows for when I am trying to grab a location, it'll get the location when it's ready. It's not forcing you to grab a location immediately. We can do that using get last known location. But it's not really forcing you to get the immediate location. It's, here's the location, give me some time to work on getting the new one. We also remove updates to any location manager because we already have the location. We remove updates also to the network listener. And then for the network listener, we do the same thing except for we change to the GPS location. And really, we don't need to get any more updates if we already received the location. Here's what got location does. What it does is it sets that result to the location result. And if it is not null, it grabs the location manager. Or I should say, if it equals null, then we should probably reinstantiate it. What this does is, if this provider is an try catch block, is it checks if the GPS provider is enabled. This checks if the network provider is enabled. If they're both not enabled, we're returning false, meaning that no, we don't have a location. If GPS is enabled, then we want to request location updates from the GPS. If network if network is enabled, then we might as well get it from the network provider too. And then I'll later on in the class, I'll show you how we decide which one is more accurate. I'll get to that in just a minute. We create a new timer, and we call this get last location. It's a class here, and it's right there. And then we schedule that for, so there's no delay really. We return true. You can probably add some delay if you're really conservative on battery life. Now, what this get last known location does is, you can see it removes the updates from both the GPS and the this one here. And this is the main class that really does all the location finding and everything. And as you can see, if they're enabled, then we grab their location from the location manager. Get last known location. Alright, now here's where we decide which one to use. If they're both not null, then what we do is, if the GPS location dot get time, if the time is greater than the network location, then we use the GPS location. And it indicates that it's fresher, it's new. If not, then we use a network location. If they're both not null, then we call the got location on both of them. And really, at the end, we call got location null because of these return statements here. Alright, and we have this abstract class called location result, and what it does is it simply grabs location. This course is brought to you in collaboration with Pablo Farias. It's also brought to you by Zenva. You can like us on Facebook at facebook.com/ZenvaDev, ZenvaDev. You can also follow us on Twitter at ZenvaTweets, ZenvaTweets. We also have great other courses on application and game development.